Hey guys, welcome to my YouTube channel. Today we're going to be learning about neuroglia. So first of all, what are neuroglia? Neuroglia are the name for cells. They are cells that are part of the nervous system that support, protect, and nourish the neurons. So first, let's look at the neuroglia that are part of the central nervous system. These neuroglia help the neurons in the central nervous system. So remember, there are two parts of the nervous system, the central nervous system and the peripheral nervous system. The central nervous system is composed of the brain and spinal cord, and the peripheral nervous system is basically all the other parts of the nervous system. So let's look at the ependymal cells. The ependymal cells produce CSF, or cerebrospinal fluid. Cerebrospinal fluid is this fluid that surrounds the central nervous system. It acts like a cushion and protects the central nervous system. It also has a function of transporting nutrients and getting rid of waste. So the ependymal cells produce that fluid. A feature of ependymal cells that almost all of them have is that they have cilia. So cilia are these projections out of the cell, these here, that wave, and then they move around. The cilia moves around, and the cilia helps circulate the cerebrospinal fluid that is produced by the ependymal cells. So they produce the fluid, and they also help circulate it. And ependymal cells are found lining the central canal of the spinal cord and the ventricles of the brain. So now let's look at astrocytes. They are the most abundant neuroglia. They regulate blood flow, and they maintain the blood-brain barrier. So, as you can see in the picture, they are star-shaped. They look like little stars. And the blood-brain barrier that they form, the blood-brain barrier is like a barrier that surrounds the brain. It's a very selective barrier. It only allows certain compounds to pass. So this way it can protect the brain from harmful chemicals, so that those harmful chemicals can't get into the brain. Some other functions of astrocytes, I don't have them listed, but here are some other functions. They guide neurons during embryonic development. They serve as a structural framework for neurons, and they control the interstitial environment around neurons. For example, they can sometimes remove excess ions, or they can remove neurotransmitter, and like that, they regulate the interstitial fluid, the fluid that surrounds the neurons. Now let's look at oligodendrocytes. They wrap around axons. So remember, neurons, they have a cell body. They have dendrites, and they have a long axon that ends in the axon terminal here. So the oligodendrocytes wraps around axons, and they form the myelin sheath. This is really important because this helps speed up the speed of action potentials, and the space between. So as you can see, there are like little rolls of it here. The space between here, this is known as the node of Ranvier. Now let's look at what microglia does. They develop from macrophages, and they're phagocytic and performs immune functions. So they protect the neurons from pathogens. They can engulf pathogens and foreign substances, so that protects the neurons from bacteria and like viruses and things like that. Now let's look at neuroglia in the peripheral nervous system. We have two. They're the cytolite cells and the Schwann cells. The cytolite cells, they are quite similar to the astrocytes of the central nervous system. The cytolite cells regulates the extracellular matrix. They may provide nutritional support and development. I say may here because we don't know that much about satellite cells yet. So scientists predict that they provide nutritional support development, and scientists predict that they also regulate the interstitial environment. Now let's move on to Schwann cells. Schwann cells looks a little familiar. They have a similar function to the oligodendrocytes that we talked about that are in the central nervous system. They also myelinate nerves, and they are important for repairing nerves after injury. So one small difference between the Schwann cells and oligodendrocytes is that Schwann cells tend to only myelinate one neuron. So as you can see, this is just one axon, one neuron, while the oligodendrocytes, they tend to myelinate more than one neuron. So as you can see, this oligodendrocyte here is myelinating two neurons. So these tend to myelinate multiple, while the Schwann cells tend to myelinate only one neuron. So similar to the oligodendrocytes, the gaps between the myelin sheath, these are called the nodes of Ranvier. So that's all I have for the neuroglia. Here are the slides credit. This slide template was from Slides Go. And yeah, thank you so much for watching, and I'll see you tomorrow for a new video.